Okay, so we're going to continue looking at sketching trig functions today, with the big difference being these trig functions will have a horizontal translation. So it adds an extra tier of complexity to it. Now, this one here is a horizontal translation. This moves the normal sine function or the 2 sine x function pi on 2 units to the right. So the way I sketch these is I first of all sketch or consider the graph of y equals 2 sine x. So our amp is 2, period is 2 pi on 1, which is 2 pi, and our scale will be 2 pi on 4, which is pi on 2. All right, let's get sketching. So let's do a Cartesian plane that sort of favours the y-axis because we've got a sketch between 0 and 2 pi. And we've got pi on 2, 2 pi on 2, which is pi, 3 pi on 2, 2 pi. Right, so what the sine function would have, there's 2, there's negative 2. It would start there, go to there, 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 and there. So what's going to happen after the translation is each of the points that I've just put down are going to move pi on 2 to the right. So I recommend getting a different color pen at this point, and what you do is you put an arrow in, new point, arrow in, new point, arrow in, new point, arrow in, new point. What's going to happen is this one here is going to move over to there. Now, what is that point going to be? So this is 4 pi on 2. This will be 5 pi on 2. And let's mark in that blue. There it is right there. Now what we can do is we can sketch this function, okay, noting that it's going to be over the domain 0 to 2 pi. So we're actually going to chop it there and not consider that point. So the movement of this one actually just shifts it out of the domain. So let's sketch what we've got so far. Okay, so that's what we've got so far. So what we're going to do is get rid of this part only. I don't know whether it's going to let me selectively erase. Yes, it will. Let's get rid of that part there. We don't need it, and that becomes our endpoint. Okay, so 2 pi comma negative 2. Now, what's going to happen here is that the movement pi on 2 to the right is actually going to bring what was happening here beforehand into the domain. So what would have usually happened, so this is the way normal sine x works, and over this side here, that's what will be there. And what it's going to do is just shift this part over. And all you basically got to do is just continue the pattern. So I just sort of know that that will go down to there and start there, because that's got to be the pattern. The pattern just holds. It doesn't do anything bizarre, these waveform graphs. Right, so that's going to be 0, negative 2. This is an x-intercept, pi on 2, comma 0. This is a maximum, pi 2. This one here is 3 pi on 2, 0. Our endpoint is marked. So we've got all the key features there. Right, so that's our first graph with translations, or horizontal translations for that matter. Now, it's always a good thing when you're sketching trig functions when the translation, this thing here, matches the scale. When it doesn't, that makes life very complicated, but we'll cross that bridge if and when we get to it. All right, what we've got here is f of x equals 2 sine x take pi on 4. So we note that that is a translation pi on 4 to the right. Okay. So again, what I do is I consider the y equals 2 sine x function and then worry about the translation afterwards. So amp is 2, period is 2 pi on 1, which is 2 pi, scale is 2 pi on 4, which is equal to pi on 2, but actually what I'm going to do is revert it back to 2 pi on 4, and I'll explain why I've done that in a sec. Right, note that the scale, the Cartesian plane will need to be set up with the y-axis somewhere in the middle, because it's got to go to negative 3 pi on 4 to 5 pi on 4, so roughly balanced on either side. All right, so we're going to mark our scale in. Now, what I'm going to do is actually use 2 pi on 4 or pi on 4 as my scale. Now I know my scale reads pi on 2, and I know that that's what we've done with all of these so far, but they haven't had this horizontal translation. And notice that I have to translate pi on 4 to the right, and wouldn't it be really easy if my scale was labelled with pi on 4s? Right, so let's do that. Pi on 4, 2 pi on 4, which is pi on 2, 3 pi on 4, 4 pi on 4 is pi, 5 pi on 4. Okay, negative pi on 4, negative 2 pi on 4, which is pi on 2, negative 3 pi on 4. All right, so remember what we do is don't worry about the translation just yet. What we will do is draw a normal y equals 2 sine x function. So there's 2, there's negative 2. So what it will do is start there, and at 2 pi on 4, which is the scale, it's going to go up, down, and over here, it'll be down. Now, before that, it would be there. All right, so what would happen is the graph would swing in like this, go like that, and continue down there. All right, now what we're going to do is do our translation now. So again, this is where I reach for a different color pen because it can get a little confusing with all these dots everywhere. So this dot is going to move pi on 4 to the right, and it'll end up there. That dot moves to there, that dot moves to there, that dot conveniently moves to the end of the restricted domain. All right, so let's sketch what we've got so far. So it's going to come in here and go like that. So sort of go like that. All right, so what we can see here is it's doing a key point every 2 pi on 4. All right, so here's pi on 4, and there'll be another key point here. So we can just finish this one off and pop that one there as well. All right, so let's start labeling. So we've got negative 3 pi on 4 comma 0. We've got a turning point here at pi on 4 comma negative 2. We've got a y-intercept, which I'll do in a sec, an x-intercept there, which is pi on 4 comma 0, 3 pi on 4 comma 2, endpoint and x-intercept at 5 pi on 4 comma 0. Right, our y-intercept. Well, what do we know about y-intercepts? They occur when x is equal to 0. So this would be y equals 2 sine negative pi on 4. All right, so what's that going to be? So sine of pi on 4, so we're going negative pi on 4, which is there. We want the sine, okay, and pi on 4 is the 45 degree, so that is going to be 1 on root 2, and it's going to be negative. So it's going to be 2 times negative 1 on root 2, which is equal to 2, negative 2 on root 2. Okay. So this value here, the y-intercept, we're going to say that when x is 0, y is negative 2 on root 2. I've seen that often simplified, so if we rationalize root 2 over root 2, and what that does is that'll give us, I'm just going to write this out a couple of times, negative 2 root 2 over 2, and what happens is those 2's cancel out to give us 0 comma negative root 2. So I often see that written like that. Now root 2 is 1.4, which looks kind of okay. All right, so we've got our y-intercept there and all key features. Let's go with this one. So G, all right, ooh, yeah, okay, this is a one to note. Okay, so notice that this 2 here, right, this function can be written as f of x equals 3 cosine, and you use that distributive law there, which is 2x plus 2 pi on 4. Okay, and that then would be 3 cosine 2x plus pi on 2. Now, many students will say that the translation of this function is pi on 2 to the left, okay? But what you want to do, just like a parabola, and I'll give you an example here. So here's another parabola. So let's go g of x equals 2x plus 3 squared. Now this parabola here does not move 3 units to the left. In fact, if we want to see how far it goes to the left, it's going to be, we take 2 out as a common factor and say that that's x plus 3 on 2 all squared. And what that will do is actually move to the left 3 on 2, or 1.5. Okay, so the same way over here, if you pull that 2 out as a common factor, what you get is a true understanding of what that translation will be. So it's going to be pi on 4 to the left, not pi on 2 to the left, as it would be if that 2 was distributed. We can see that that's kind of come up in the next problem. Right, so let's go amp. First of all is 3. Our period is going to be 2 pi over this value here. This is the n value here. That's the coefficient of x, okay? So we're going to go 2 pi on 2, which is just pi, and our scale is going to be pi on 4, which matches the translation, which is good news for us. All right, so let's get the sketch going. So I'll do this sketch in blue and switch to red for the actual graph. Oh no, let's do it in red. Okay, so scale, so we're going to go pi on 4, pi on 2, 3 pi on 4, pi, 5 pi on 4, 6 pi on 4, which is 3 pi on 2, 7 pi on 4, 2 pi. Okay, so remember what we're going to do is just draw a normal cosine graph for y equals 3 cosine 2x. All right, so cosine starts high, so we're going to put our dots in. So high, go to there, 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 and there, which is one cycle, which matches the period. All right, now let's take care of the translation. So what's going to happen is this translation is going to move this function pi on 4 to the left. So that's negative pi on 4 there. So what will happen is that point will move to there, that one there. Let's change colors so we can see this a little better. So that point goes to there, that point to there, that point to there, that point to there, that one to there. All right, let's sketch the cycle so far, noting that our domain is 0 to 2 pi. Okay, now remember what would happen is it would turn there, cut through there, and turn there. So this is going to come off on a fairly steep angle. It's going to ease into the turning point. All right, what's it going to do there? So we can see here that we're getting a key feature every pi. All right, so it'll go back down to there. So basically, I'm just completing the pattern. All right, so that's what we're going to get. A bit wonky over here. It's probably because my scale wasn't evenly spread out. So make sure when you sketch these up that you do kind of measure your scale to make sure it's going to look sort of symmetrical. Okay, so 2 pi, comma 0, 7 pi on 4, comma not 0, 3. X-intercept 3 pi on 2, comma 0, 5 pi on 4, 3 pi on 4, comma 3, yada da da da. Okay, 0, 0 for the origin. Make sure you label all key features. All right, let's go H. How many more sketches? 2 more. Okay. All right, we can do this. All right, so this looks like it's a translation pi on 4 to the left, but it's not. So what we want to do is to really see what the translation is. We want to rewrite the function f of x equals 2 cosine, and we're going to yank 3 out, x plus. So we're going to divide pi on 2 by 3, which will give us pi on 6. Let's just check it out. 3 lots of pi on 6 is 3 pi on 6, which is pi on 2. Right, so we can see that the translation is pi on 6, okay? All right, so let's work out what we've got. Our amp is 2, period is 2 pi over 3. And our scale is going to be 2 pi on 3 over 4, which is going to be 2 pi on 12, which is pi on 6. Now again, that scale matches the translation, which is very convenient. 0 to pi. That looks wonky. 270. 0. Perfect. Okay. All right, so let's pop our scale in. So noting that pi on 6, we need 6 of them to get to pi, so make sure you space it out so you're not going to max out your scale. So that's pi on 6, 2 pi on 6 is pi on 3, 3 pi on 6 is pi on 2, 4 pi on 6 is 2 pi on 3, here's an actual 5 pi on 6, and pi for 6 pi on 6. All right, so remember the basic idea now is that we put in points for f of x equals 2 cosine 3x. Don't worry about the translation yet. Okay, so it's cosine, and we've got a -3, whoops, -2 and 2. Cosine starts there, we'll go there, 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 there. Right, now what we've got to do is do the shift. So this is going to move pi on 6 to the left. Okay, so change your color. That one is going to go to there, that one to there. Right, and generally that's all right. Once I've got that, I don't really need to move the other points because I can see how the cycle is going to continue. So down it goes, up to there. All right, label off. Okay, it's a bit of a pain, but go through the pain, it's worth it. You'll always remember to do it. Endpoints, cool. All right, last one. Okay, yeah, I think this one's going to be tricky. Okay, so let's rewrite the function in a way that we can sort of see exactly what's going on. So 2x take pi on 8. Right, so our translation is going to be pi on 8 to the right. Let's do our grunt work. So our amplitude is 3. Period is 2 pi on 2, which is pi. Our scale is going to be pi on 4. But what I'm going to do is rewrite the scale as 2 pi on 8. Because what I want to do is I want to have the flexibility then to do the translation pi on 8 based on having a scale of an on 8 scale. All right. Now I need it from -7 pi on 8 to 7 pi on 8. So let's put this thing together. Let's balance it up roughly in the middle. Okay, what is it? 3? Is that one? Oh, okay, so let's try that again. So we've got 3 and -3, and we need pi on 8. So let's go pi on 8, 2 pi on 8, which is pi on 4, 3 pi on 8, 4 pi on 8, which is pi on 2, 5 pi on 8, 6 pi on 8, which is 3 pi on 4, 7 pi on 8. All right, let's go back this way. So this is negative pi on 8. Once you've got the positive done, it's easy to do the negative. All right, now remember what we do. We just basically sketch or put points in for one cycle without the translation. So let's forget the translation for the moment. Right, so what we're sketching is y equals -3 sine 2x. All right, noting that our scale is 2 pi on 8. All right, so it's negative sign. The sign would start at 0 and typically go up. Okay, but this one isn't. It's going to go down. All right, our first key feature is going to appear at 2 pi on 8 or pi on 4. So it's going to go that to there to there. Okay, so it's going to go like that and we'll swing down and would hit it at 8 pi on 8, which is pi. So that's good. Those points have ended up in the right spot. Right, now what do they want us to do? They want us to translate pi on 8 to the right. So there's pi on 8. So you can see why it's important to think ahead and to label your scale accordingly, because if you label it with what scale says to label it, which is pi on 4, you've got to kind of visualize where pi on 8 is, and it just gets really messy. Right, so we're going to move that one to there, that one goes to there, that one to there, that one to there. All right, let's just sketch this cycle and see what happens. Right, so there we go. So what would happen then is it would have a key feature there at -2 pi on 8. So this is where we go back to red here. Just go, all right, so we go down. So this would be the up, and it would be down. Having to really think here. And then like something there, right? So again, let's move these points. That to there. Okay, so let's sketch that. And so you can see here, you're going to have one at negative there, so it's actually going to go to there, because again, we can see that the intervals, every second thing in blue gives us a key point on the sine function. So there we go, we got it. Right, so endpoints are included. So let's start labeling. 7 pi on 8, 3. This one is 5 pi on 8, 0. This one is 3 pi on 8, -3. This one is pi on 8, 0. Got a y-intercept that we'll do in a sec. This one is negative pi on 8, 3, etc., etc. Okay, I'll let you finish off that, noting that that endpoint is also an x-intercept, so you would have labeled it anyway, but endpoints have to be labeled when we've got a restricted domain. Right, so what's the y-intercept? Well, the y-intercept occurs when x is equal to 0. Okay, so that's going to be 0. So this is going to be, so f of 0 will be -3 sine negative pi on 4. All right, negative pi on 4 is here. That's going to be negative. So it's going to be -3 multiplied by 1 on √2, which is going to be negative, which is going to be 3 on √2, which is this value here. Now 3 divided by 1.4, it's roughly 2. Like, the scale's not fantastic, but yeah, I mean, remotely that could be roughly 2. Okay, so I'm just going to go with that. So when x is 0, y is 3 on √2, and we've got our full sketch. Right, so the work now will be to continue sketching, and there you go. It's those ones there, 14I and 14J. All right, so good luck with that, and let me know if I can help out with any of those sketches.